Welcome to this, I have to check the day of the week, this Wednesday morning live stream, most recent iteration of my virtual office hours, so thanks for joining. It's been a little while since I've had a live session in this traditional form. I've been traveling a lot. You may have caught my talk at the National Academy of Sciences down in Irvine. If you missed it, I'll add a link later on to the comment section on hydroclimate whiplash. But there's a fair bit to talk about today on the topic of active weather in California in the coming days. In fact, it's been unusual in a different respect the past couple of weeks. Very, very warm and mostly dry weather, not just in California, but throughout a lot of the West. So I'll talk about that, including some record warmth. That is just about over, based on what is on, in some cases, literally on the radar right now. And that reminds me that I should probably pull up one more link for everybody that I didn't already have up in the background here with satellite imagery. So we'll add that to the queue for sharing live in a little while. And then, in addition to talking about the relatively active weather pattern that California is going to be experiencing in the coming days, I also wanted to talk, or actually offer a brief, maybe 15 or 20 minutes, something like that, Ask Me Anything window at the end of the session, but ask me anything pertaining to the Bill Gates climate memo that's come up in so much recent discussion as of late, as well as the response to the response to the response in some cases, since this has garnered a response both in the media from lots of pundits and from Bill Gates himself. So we can talk about that if folks are interested, but I don't have prepared remarks. I'm going to open the floor to questions about the memo itself, the background context surrounding it, and also my personal response, including the video op-ed, which is the first link I've shared in the comments section today. I won't fault anybody if they take a brief moment away from the live stream to watch that for some context. But as is often the case, today is a split between short-term weather and some big picture stuff. I will also mention that we are still, despite recent political movement, in the midst of a federal government shutdown in which all of your National Weather Service public servants serving your area, as well as the folks running all of these federal entities that work to protect life and property on a daily basis, are continuing to work without pay. We're going past 40 days now, the longest government shutdown in American history, certainly in contemporary American history anyway. And this is probably having the most newsworthy impacts when it comes to air travel disruptions because of the lack of available air traffic controllers and other critical staff. But of course, this is also happening behind the scenes at places like the National Weather Service or the U.S. Geological Survey, places where you really want people there at 24/7 without distraction, working to protect life and property. And they are still there in most cases 24/7, except where workplace attenuations through reductions in force, RIFs as they're colloquially called, or the earlier firings by Elon Musk's Doge entity, have actually reduced staffing levels below 24 hours a day in some cases, as I've talked about. So the current shutdown stresses are on top of the critical staffing stresses that already existed prior to the remaining employees in these places no longer being paid. And again, despite the reports of some movement politically, it has not been resolved yet. The government is still shut down, and all of these folks are still working without pay. All right, so let's talk about the weather. And maybe first what I'd like to do, actually, I'm going to start sharing my screen. I'm going to go first to satellite imagery. So let's get that going. You'll see my infinite mirror first, and then you're going to see some satellite imagery here. Let's actually zoom out to the even bigger picture here, because this is one of those days where the real big picture is helpful. And I'll double check this is coming up as expected here. Yep, that's what I was hoping. Okay, so we've got, let me bring my drawing tool up as well. We've got a nice looking weather setup over the Eastern Pacific at the moment, including a nice, let me change the color here to, I don't know, let's go for hot pink because it's the greatest contrast with everything on screen. We have a nice low pressure system over here out over the Pacific. You can see all of this popcorn convective cloudiness, this open cell cumulus as it's known, and the cold, relatively unstable air behind where the cold front is, which is somewhere in here. This is my poor representation of a TV weather person drawing the cold front on screen. It's somewhere in there. But ahead of that front here, and the cold air, of course, is coming down sort of behind the front and behind the front like this. So that's the cold air, as is usually the case. Gulf of Alaska air is the colder air. It's not extremely cold, but it is certainly colder in relative terms. We also have flow ahead of the front, roughly from the southwest to the northeast. You can see that in the direction that the clouds are largely moving in, and this is the warm air. It's also the moisture air mass, and it is, as I mentioned, warmer than usual because of the warmer than average ocean surface temperatures in this whole region. That kicks up the boundary layer temperature, boundary layer being the lowest level of the atmosphere, as well as the amount of moisture in it, as we've seen repeatedly. So there's lots of clouds over much of California today, a mix of high clouds in the south and lower clouds in the north, and then some clearer spots, looks like, over the mountains right now. But this is a general sense of the setup we've got right now over the Pacific. And this storm system is going to make it to the California coast. This is not going to be one that dies or shifts away. This one will bring significant rain and some wind and maybe even some thunderstorms to some parts of the state over the next few days. And probably, I mentioned there was some stuff showing up on radar right now, but none of it is all that exciting. Most of the interesting stuff is still a little bit too far offshore to see with the terrestrial radars over California. There's probably some thunderstorms going on here out over the open ocean based on what the clouds look like, but those will move in later today into tomorrow once they come into radar range more squarely. So that's a preview. Well, how has it been recently? Well, thanks. If we go over to the climatetoolbox.org, look at recent climate conditions, big red blob, western U.S. Again, this is over the last 15 days, so about the last 2 weeks, so from a couple days before Halloween to a couple of days ago. So it's not perfectly aligned with the first half of November, but this is pretty much what the map for the first half of November is going to look like. Very warm, in some cases record warm, particularly across the Great Basin and inland portions of Southern California, but this warmth did make it all the way to Northern California. It made it all the way to the California coast, all the way from San Diego to the Oregon border. So this was a genuinely anomalously warm period across all of California the past couple of weeks, and indeed most of the West. And if we look at just how unusual those temperatures were in the context of the last several decades, we find, in fact, that the last 2 weeks probably were record warm or near record warm in some locations in California, particularly, again, in the Sierra Nevada and then in inland and mountain portions of Southern California. Not record warm in the Bay Area, in Sacramento, or in LA proper, but in the hills just above, it probably was. This is a pattern we've seen before, although unlike earlier this summer, it's not like it was cool at the coast or in the valleys. It was still much warmer than average. It just wasn't near record. So this was a very warm period, and there were a couple of individual days where there were record highs even in the LA Basin and the Bay Area. Of course, record highs in November means something different than record highs at the peak of summer, although in Southern California it still did get up into the upper 90s last week, which is remarkably warm, as I mentioned, but not, in some cases, not necessarily record-setting. Well into the 70s and 80s in Northern California, it's been a warm period. But because it had also been a pretty wet period, so if I look at the precipitation anomaly over the past the last 15 days is not that meaningful, but if I look over the last 60 days, we see that in fact it has been a wetter than average period across much of the Southwest. In fact, there's very few drier than average areas. So all of California was either near or above average precipitation for the last 60 days. And this is especially true in the interior part of Central California, where it's probably among the 10% wettest mid-September through mid-November periods on record. So notably wet in Central California and still wetter than average anywhere where you see green. This has helped keep the wildfire activity to a real minimum because we had significant rain that preceded this autumn heat and any significant wind events to come. So that's great news from a wildfire risk perspective. It's meant that there's been a ton of prescribed burning going on, especially in Northern California, but also in parts of the Southwest along the Mogollon Rim, among other places. So this has been a pretty favorable period from a fire perspective, a minimal risk of dangerous fires and good conditions for prescribed burning. So this has been a pretty good fall, all things considered there. I know it's that order of operations with the early rains have screwed with some of the agricultural growers in the Central Valley. Certain crops don't like that early rain. But from a landscape level, ecology, and wildfire perspective, this has been a really fortuitous sequence, particularly because we did get that record heat later in the fall, but it followed significant rainfall, and so we really didn't see any meaningful fire activity as was predicted. So again, fuel moisture matters. I'll just say that over and over and over again because we continue to sometimes miss that, and that goes both ways. Sometimes fuel moisture matters, and if it's really critical, that's really alarmingly concerning. But fuel moisture also matters in the other direction, and even if it's the air is dry and the temperature is warm to hot, and even if it's windy, if the vegetation is not especially dry or if it's recently rained, we do not have the same level of wildfire risk as you would with drier vegetation conditions. And I realize this sounds obvious, and it's not a perfect on-off switch. You can still see fires when the vegetation isn't critically dry, but they just aren't the same. They just aren't as dangerous. They aren't going to move as fast. They aren't going to burn with the same thermal intensity, and maybe most importantly, they aren't going to threaten your home in the same way that grass fires, brush fires, forest fires under much more intense ambient dryness conditions will. So we don't have that now, and the other good news is that moving forward, it kind of looks like we're going to see a fire season knockout rain event in the next week, pretty much over the whole state. So I'll talk about that in a minute. So I do think that fire season had already been over in Northern California. Now, within a few days, it may be the window is probably going to be closing in Southern California as well. Again, that does not mean that there will be no fires definitely for the rest of the remainder of fall and winter. If there's a prolonged dry spell, Santa Ana winds, conditions can always pop back up. But in terms of extreme fire risk conditions, I think after getting another 1 to 4 inches of rain in the coming days on top of the already above average precipitation we've seen in Southern California in recent weeks, this does not look like a winter where there's going to be an appreciable risk of very large fires unless it suddenly becomes bone dry for the rest of winter, which we can't rule out. But of course, the more rain we get now, the less consequential extended midwinter dry spells become because of all that antecedent moisture. So this is largely good news there, especially from a fire perspective and also from a drought perspective, because there is a chance that the rest of winter will still be drier than average in Southern California, but that will be tempered. The effects of that will be tempered somewhat by the rain we've already gotten and the rain we're going to get over the next week or so. So what is the forecast for the next week or so? I just pulled up here this handy little plot. Again, this is for a point near Los Angeles International Airport. So think of this as somewhat representative of the coastal plain in LA County. Again, this is a time series plot, so a prediction from today, November 12th, moving forward in time out 2 weeks. And each of these is an individual member of the European Model Ensemble. So each of these is an equally plausible prediction for how the next 2 weeks might unfold on the basis of just slight perturbations of initial conditions. And as always, you see that there are quite different outcomes with very tiny perturbations in initial conditions, meaning that essentially we give the weather model infinitesimally different estimates of the current state of the atmosphere at the time the prediction is made, and they diverge in their solutions pretty quickly in terms of specifics. However, can you see general patterns emerge across the ensemble? Absolutely yes. And in this case, there's a really clear pattern here where we, I think virtually every member, all 50 out of 50 ensemble members, have significant rainfall in coastal Southern California beginning around the 14th. So in about 48 hours, that's about when this rain starts. And there's a pretty good consensus, in most of them anyway, that this will last for several days and end around November 17th or 18th. So that's several days of potentially significant rainfall. Look at some of these members that are quite wet, and even the driest ones are still on the wetter side. Consensus also that there'll be a break somewhere right around the 19th to the 20th before there's a chance, although there's, again, you can see the range, the ensemble, a 50-50 chance of a secondary round of precipitation out towards the 21st, 22nd. But the real high confidence here is what we've got in the coming days, starting in about 48 hours and continuing for 3 or 4 days thereafter. And how much water might this be if I select the cumulative precipitation model, estimate here? These are pretty robust numbers for Southern California in November. Again, so this is the ensemble average for a point near the LA coastal plain. We're talking about an ensemble average of about 3 inches of liquid equivalent, and that's mostly going to fall over a 3 or 4 day period starting in about 48 hours. That's quite a bit of rain for LA in November. As you can see, there are some individual members that are quite a bit wetter. There's also a couple that are drier, but notably even the driest ones are really around an inch or so, which would still be a respectable soaking for Southern California in November. So the range is from decently wet to extremely wet, and the most likely outcome is somewhere in between, which is, let's just call it, pretty wet. This is a great example, by the way, of why you shouldn't rely too much on the individual number one control run for the model. The control run is just, you could call it our best estimate of the initial atmosphere, but it's not necessarily that much more likely than any of these other outcomes. In this case, it looks like it's among the wettest of all members, showing almost 6 inches of rain between Friday and Monday in Southern California, which could cause some problems. But of course, that's pretty high in the upper tail. There's a couple of members that are a little bit wetter than that, so it's not impossible, but the majority of these are not nearly so extremely wet as the current control run of the European model. So just a nice illustration that the most likely outcome is not the most extreme outcome. But we also can't rule out significant precipitation. So in any case, this looks like quite a wet pattern for Southern California in the coming days. If we take a look at what this might look like in Northern California, so say, let's pull up, let's see if we can do San Francisco. This is a semi-alphabetical list, so it's always a little bit confusing. Yes, let's look at San Francisco. We actually see that precipitation totals are probably going to be lower in Northern California, especially for this first wave. It'll still be a solid soaking, probably about an inch of rain in some places, and maybe an inch or two in the mountains, maybe a little bit more than that. But LA actually stands to see more rain from this initial wave of precipitation than does San Francisco, which is notable. Although San Francisco will probably see Bay Area northward, North Coast, more wind from this. But here we see that there's a higher likelihood of Northern California of a follow-up system. So the first system looks more significant in Southern California in the next few days. It's the second system that looks more significant in Northern California. It might not make it quite so far south. But the end result is that it looks like a relatively wet period for the next week, within the next week especially, for Northern and Southern California. And there's a bit more of a question mark after that, but it still could be a fairly wet pattern then too. I'm going to double check on the questions here. Okay, so let me close a couple of these tabs so I don't start to run out of the memory in here. And I'll close this one as well. Okay, so what's the big picture look like right now? We have, let's just All right, so here again is the 500 millibar geopotential height anomaly map. It's essentially saying how anomalously warm or cool is the lower half of the atmosphere. The oranges and reds are warmer colors, correspond to actual warmer temperatures and thicker atmosphere. Blues, cooler, and a thinner atmosphere in terms of the height of that half mass layer. What we see right now over the next 5 days, as you would expect, is a trough developing off the coast of California. Notably, it really is off the coast of California, not so much the west coast in general. So this is more of a localized low. California is going to be wetter than the Pacific Northwest during this period. We have a pretty big ridge over the central U.S. This is leading to really warm temperatures, record warmth even in the central U.S. in this period. But the other point I just want to emphasize is that take a look at this gigantic honkin' ridge over Greenland, this Greenland high. This is known as a high latitude block, so a blocking ridge, blocking high pressure system. When we see this near Greenland, it tends to result in a very wavy pattern in the Northern Hemisphere jet stream, and we can kind of see that here. In fact, if I zoom out to the whole Northern Hemisphere, let's just, haven't even looked at this yet, but let's just see, yep, there we go. We can kind of call this, if you will, a wave number 1, 2, 3, 4, 5. So this is a wave number 5 pattern because there is 1, 2, 3, 4, 5 wave peaks. And this is also known as a negative Arctic oscillation pattern, where there's more mass than usual in the Arctic. There's more and there's less in the mid-latitudes. So essentially, there's a displacement of atmospheric mass, literally of air, from the Arctic to the mid-latitudes, and it does so and certainly creates this wavy pattern. And if we move forward in time, this is the present moment. Let me let's see if I can click here without. The tricky part is, okay, yes, I can do this way. We see that the trough, it's kind of a persistent pattern. This trough, this is going out to the end of November, kind of lingers near the west coast. It shifts around a bit, and there's a ridge in the Gulf of Alaska, but this low pressure system near California kind of persists, as does this ridge in the eastern U.S., and as does this Greenland block. So this Greenland block kind of sticks around. This ridge up in the Arctic, it shifts a little bit. The ridge, the high over the Gulf of Alaska persists, and this pattern, if I toggle back and forth, well, I can't do that with the screen brush on. But anyway, it's kind of a stuck pattern. It's going to be kind of persistent for the rest of the month. Here's a great example, by the way, of how even when we have high pressure in the Gulf of Alaska, it does not necessarily mean dry weather for California. It means, well, there's going to be a ridge here, but where's the trough? If the trough is more like this, that could well be a dry pattern for California. But if the trough is more like this, then that actually can be quite a wet and active pattern for California. What does this look like in terms of temperatures is maybe the more interesting question, so I will bring that up with a slightly zoomed North America map again, and we're starting out warm even in California, even as the rain begins. So this will be a fairly warm, the first storm is going to be a warm one with very high snow levels, above 8,000 or 9,000 feet in most cases. So the Sierra Passes, lake level, probably not going to see more than call it back end slush, maybe some non-accumulating snow at 6,000 feet. As the cooler air filters in after the cold front, but really only seeing big accumulations at really high, like 9,000, 10,000 foot plus elevations. Subsequent storms later in November will probably be colder if they occur. Those will probably have the better potential for snow accumulation. So you see this really warm conditions, including in the west. A mile up in the Rocky Mountains, it's been 60 and 70 degrees, even late in the evening and early morning hours recently. But that will start to go away as this trough starts to dominate the west coast. To be clear, this is not extreme cold. This is only slightly cooler than average temperatures, but it's a broad region of them, and there's pretty high certainty that will occur. But if you notice, in the Arctic, look at that extreme warmth from that ridge. I mean, we're talking about surface air temperatures maybe 15 or 20 or even more degrees average Fahrenheit above, degrees Fahrenheit above average at very high latitude places, continuing for the indefinite future. So it kind of just, if I go back and I go forward, it's just a lot of purple up in the Arctic, even as the red and blue blobs move around North America a bit over the time. And you may notice this not extreme but persistent sort of warmth in the tropical Pacific down here. That's arising again from these warmer than average swath of ocean surface temperatures in this region. There has been cooling in the Gulf of Alaska, so due to storm activity recently, so that's a bit of a change from recently. But the California coast, again, the ocean temperatures remain, as they have been for the past couple of months, much warmer than average. And the storm track region, the subtropics and the exotropics between California and East Asia remain much warmer than average as well. We've also got a pretty robust La Nina event currently in place. We also have this V-shaped warming pattern in the Pacific in general. So we have the warm water up here, and we have the warm water down here. This is the warm, and then the cool here. We've seen this pattern a lot in the last few decades. There's recent research suggesting this might in fact be a climate change signal, the spatial pattern of warming, which is not necessarily something that climate models had initially indicated, so there's a lot of active research. But in any case, this does generally, this V-shaped pattern of SST warming in where the western Pacific is really warm and the eastern Pacific is really cool, and there's a swath of warm water in between, just like we have this year. That has historically been associated with significant ridges in this region. So the jet stream in these winters tends to like to do this. Now the question is, the million-dollar question, or multi-million-dollar question as it often is, will the ridge do this? And, well, actually maybe I should draw this more carefully. Will the ridge do this and keep California drier in the winter, or instead will the ridge do this, like it is right now, and allow some of those Gulf of Alaska systems to dive down the eastern side of the ridge and actually bring some pretty wet conditions to California? I don't have the answer to that, but I can tell you what the seasonal models are saying, but with the caveat that whether the ridge ends up here versus here, I'm quite confident it'll be somewhere in that range, but whether it's in location 1 or location 2 really makes a big difference for whether California has a wetter or a drier winter, and also for snow accumulation, especially in the second half of the winter. But let me not get ahead of myself. I'll show that in a minute. What does the storm actually this week actually look like in California? And for that, I will zoom in considerably farther and go into the southwestern U.S. Okay, so this is right now or earlier this morning. The storm looks pretty robust. That's a decent low pressure system, 984 millibars. You can see the closely spaced isobars, lines of equal pressure here. That's an indication of a strong pressure gradient or differential at the surface, which of course is what drives winds. And I haven't looked at this yet, but just from Meteorology 101, there should be a region of quite strong winds here. If we take a look at the lower atmospheric winds, let's just see if they're present. There they are. So we see some about a mile up above the surface, near hurricane force winds blowing, or even greater than hurricane force. Of course, this is not at the surface, and it's much more common to have strong winds aloft and at the surface. There's always a reduction factor, but those are rather strong. What does the surface look like? Right, let's call it the 10 meter or 30 feet above the ground level. Of course, there's still some quite strong winds associated with that strong pressure gradient. You see that there. There's even an area over the open ocean of 55 mile an hour sustained winds. And along the coast, as this comes inland, especially along the north coast, along the north coast and maybe into the San Francisco North Bay, some pretty strong sustained winds and gusts along the coast into tomorrow. And there are high wind warnings in effect from about Marin County coast northward into the North Coast region. Again, does not appear to be an extreme windstorm, but it is certainly the windstorm that could bring down some tree branches and power lines and that sort of thing if you are in the hills along the coast from about Marin County northward toward the Oregon coast. But for everyone else, the more consequential bit will probably be the precipitation, which, let's take a look at the timing of this. There could be some light rainfall as early as late afternoon, evening, so some light rain, Bay Area maybe for the evening commute today, but the real big stuff holding off, it looks like probably until the overnight hours. So this will be an early morning cold frontal passage, it looks like, right now in the central Bay Area tomorrow morning. And it looks pretty robust. Some heavy or even briefly torrential downpours, some isolated thunderstorms are possible, some strong gusty winds. This might mostly move through the central Bay Area by the primary morning commute, or it might be sort of sticking around at the tail end of it. This cold front will move into Southern California. It isn't going to fall apart. In fact, it tries to fall apart along the central coast, but then it kind of gets juiced up by the injection of some subtropical moisture as we go into the weekend. And then there's a secondary system. This low pressure system actually develops its own warm, moist, atmospheric river type flow over Southern California, producing potentially some quite widespread and significantly heavy rainfall along with some thunderstorms into the weekend. So Saturday and Sunday in particular in Southern California, before yet another system moves through Northern California. This one might be the colder one, by the way, with a greater potential for snow accumulation next week. If I go back in time again, you'll notice this system is going to bring almost entirely rain in the Sierra Nevada on Thursday. Really high snow levels. We're talking like 10,000 feet. And in Southern California, they'll be probably above the tops of the mountains in particular. So this will be really warm. If I show let's show the 250 millibar temperature anomaly. You can see we're starting out warm. This is again about a mile above the surface. Even as this storm moves through, we don't really see the kind of major cooling over land that we normally do following a cold front. That cold air stays mainly offshore. The mountains actually remain in some cases warmer than average, even as precipitation falls, with some pretty relatively warm in relative terms, air wrapping around the system to the north. Let's look at what the actual temperatures are. 850 millibar temperatures, which is often a good indication of snow levels, and as you can see, they're well above freezing. 850 millibar temperatures don't come anywhere near close to even coming close to freezing until next Monday or Tuesday, and even that's only in Northern California. So this is not going to be a good snow producer for the mountains in California, but it could well be a very excellent moisture producer, especially for Southern California. And again, as I mentioned, I think this operational run might be overdoing the rain in Southern California. It shows some very heavy totals. LA County, like 4 or 5 inches in LA. This is just one model run, just for perspective. Here's the American model run, which actually shows even higher totals, but in a different place. This is more in the mountains of Santa Barbara County, showing some 5 or 6 inch totals in the mountains there. If we look at the ensemble, which is almost always a better approach here, still showing quite a bit of rain in some places, again, on the order of 2 or 3 inches across most of coastal Southern California. So this will be a big precipitation event in coastal Southern California and a big precipitation event for the Sierra. But note that I did not say snow. Most of this will be rain. So several inches of rain will fall all the way up to 7,000 feet. Some heavy wet snow at very high, like 9,000 plus foot elevations, and maybe some light slush that melts at lower elevations in the back end of the storm. This is not going to be a huge precipitation event for the Bay Area, maybe an inch, which, we'll take it, but, it's not nearly as much as we're expecting in LA. So this is an unusual situation where coastal Southern California actually might see some of the highest rainfall totals from this event, possibly outside of some of the highest elevations of the Sierra. And along with that, what we've got here, let's show this first. Here's a current snowpack summary for the state of California. As you can see, there's little or no snow on the ground. You can maybe see a little bit at the very highest elevations, but in the southern Sierra, there's essentially no snow at all. We're talking about like 6 or 18% of the average for this date in early October. Now, to be clear, no, you know what? Actually, I take this back. This says data as of June 2025. So this report may not have updated. I'm just noticing that now. My apologies. let's see here. Well, yeah, looks like we're sort of stuck in June on the California Department of Water Resources website. So actually, I don't have that data in front of me right now. So my apologies. We still don't have a great deal of snow following 2 really warm weeks, but I do not actually have that live data in front of me now. So I won't belabor that point. The other thing I wanted to point out here is that there could be some thunderstorms with this event, and we've been seeing this with almost every system this fall so far, where there's been some significant thunderstorm activity in California. I think this is, it's partly because, again, the oceans near California are warmer than average, and that's adding a bit of extra low-level moisture and a little bit warmer temperature to that lowest level of the atmosphere. Again, these are not extreme levels of instability. We're talking about, CAPE along the cold front, convective available potential energy of like 200 to 400 joules per kilogram, which if you're on Tornado Alley, that's just a rounding error. But if you're in coastal California during a winter storm, that is enough to generate heavy downpours, some narrow cold frontal rain bands, and probably some isolated lightning, brief isolated low-topped supercell spin-ups of waterspouts and things like that. So, and I'm just sort of clicking randomly through the next few days. Almost every day is going to be at least a few hundred joules, and here we're getting up to closer to 500 joules per kilogram of convective available potential energy, first in Northern California tomorrow with that initial cold front, and then possibly this weekend with that subtropical moisture coming up over Southern California. If I show, let's take a look, upper air moisture. I'm just trying to figure out what we actually want here to show just how much moisture there's going to be in the atmosphere. There's a good one. Precipitable water. So these are going to be quite a moist air mass, but let's actually look at the anomaly. Again, despite the name, precipitable water does not mean precipitation. It means the amount of moisture in the atmosphere that's potentially available for precipitation. So it's a bit of a tortured piece of meteorological jargon. But in any case, this is the anomaly. So here, where you see greens and especially blues, there's much more moisture than usual. And again, these are pretty large. There's about an inch of additional precipitable water with this initial cold front over Northern California. But you can see this mass of subtropical air in Southern California that tries to get integrated into this secondary cold front as it stalls out this weekend over coastal Southern California. This has been a bit of an evolving situation, and there is some potential flood risk over Southern California because this is a system that will be lingering for at least a couple of days and will have a lot of subtropical moisture. And sometimes the models don't always handle this so well. So between essentially Friday and Sunday, there is a risk of some flooding, particularly near recent wildfire burn areas and in steep watersheds. We'll just have to see how that goes in the days to come. Okay, and then finally, and I want to leave time for the Ask Me Anything session, so I'm just going to quickly take a look at this seasonal outlook ahead, and I'm not going to spend too much time on this except to say we're likely to see, well, let's see here, La Nina is probably going to persist for most of the rest of the winter, so we'll continue to see the effects of that, but that could start to change, and there's some indications of a flip toward El Nino conditions as soon as late spring. We'll talk more about that a little bit later. There's still a tilt in the odds, by the way, in Southern California toward drier than average conditions this winter, but that's not what we're seeing right now or this month. It does not mean that the seasonal forecast can't ultimately be right, but it does mean that the consequences of the seasonal outlook being right regarding a tilt in the odds towards a drier than average core winter won't be quite as consequential as it would have been had we not had the rain that we're getting now. In Northern California, there's not really any precipitation signal this winter. Could go either way. There's a tilt in the odds towards wetter conditions in the Pacific Northwest. When it comes to temperature, again, it's kind of like let's just say, catching fish in a barrel to predict a warmer than average winter these days over most of North America in a warming climate. But what's interesting is that as we do get toward January and February, there is actually right now a pretty strong consensus of some not warmer than average temperatures over Western Canada and Southern Alaska. This may be related to some polar vortex disruption and a lobe of vorticity sitting over Western Canada later this winter. That could potentially set the stage for some later season cold air outbreaks, particularly given the geopotential height anomaly pattern that we expect to see later in the winter. This is a notable pattern as we go to January. I'll just suggest what this means. Again, as I pointed out earlier, exactly how this plays out in California remains to be seen, but at face value, this would suggest that later in winter there's a decent chance for some colder Gulf of Alaska systems to dive southward, maybe giving us some decent Sierra Nevada snow accumulation as this persistent ridge trough dipole pattern sends a jet stream somewhere like this. Now the key is going to be, is it more like this or is it more like this? If they're off by 500 miles, that could be the difference between a really dry winter in Southern California and a fairly snowy winter in the Sierra Nevada. But I do think that this high amplitude flow pattern, potentially it looks like this is starting to be induced by this polar vortex disruption, which a lot of the seasonal models are projecting for later this season. That could result in a pretty wavy jet stream pattern later in the winter with some interesting surprises there. So I'm going to leave it at that for now. All right, so I'm bringing myself back on full screen, and this is now officially the Ask Me Anything part of the session. Once I get through, let me just answer a few questions that have already come through, and then we'll open it up to the climate memo related Ask Me Anything session that I promised everybody. All right, so I'm just checking out the comments here. Take a sip of water. It's been a while. I think I did answer those questions about the ocean temperature anomalies. Question: did I see the Northern Lights last night? So here in Boulder, Colorado, I did see. Unfortunately, I wasn't able to go out where there were fewer lights or an expansive northern horizon last night. But despite that, there was a pretty substantial display, even in the context of suburban light pollution and not having a good northern horizon. So that was a pretty extraordinary event. Then I am not a space weather expert. In fact, I am pretty much in the same category as anybody else as a space weather amateur, but it does sound like there's a potential for a similar display tonight. So if you have the ability to plan, question is though, at least in Northern California, unfortunately, there's probably going to be a lot of clouds. You might get lucky in Southern California, though, if you can get somewhere away from the light pollution, or if there's breaks in the clouds up in Northern California, sometimes that can actually be pretty cool unto itself. So that might happen again tonight, because that solar storm activity actually has continued today. We'll see how that plays out. But I'm not a solar heliophysics expert by any stretch of the imagination, so unfortunately I can't discuss the magnetosphere, for example. I have to go with someone else for that one. Is the question, any comments on the shutdown of the 9 seismic monitoring stations in Alaska? The concerns for tsunami warnings on the West Coast? Yes, this apparently has happened unrelated to the shutdown, and this is apparently something that's going to be permanent, to my understanding, based on public reporting. It's not great, but there's a lot of other things that are getting shut down too, in terms of safety and monitoring of any number of things, from zoonotic viral pathogens to tsunami waves to weather balloons, used in weather forecasts. So, it's really across a wide spectrum that we're seeing similar decimation of essentially what are directly public safety relevant federal functions. Let's see here. Yeah, as a comment from Mary, this time of year, the saying sometimes goes that the storm door is open, and I think it's fair to say, at least for the next couple of weeks, the storm door will indeed be open for California. That's a reasonable way to put it. Although I will say that this is not necessarily because we have a screaming jet stream pushing lots of storms toward California quickly. This is actually because we have a wavy jet stream. It's not even that strong, but it's in the right position to allow these persistent low pressure systems to kind of get stuck near California and not move very much, which also is another way to get persistent rain and storminess, which is probably what we'll see. It's a question from Matthew: why is every storm on the West Coast called an atmospheric river now? Is it just a linguistic fad or media hype, or is it an actual increase in ARs? This is something where it is primarily a question of communication in the media, and it is true that the term is used more often, and that certain events that would not have been described as atmospheric rivers 15 or 20 years ago now are. That is the main thing here. I don't think it's ridiculous to call them that. In fact, it turns out that we just that's an intrinsic part of the climate on the West Coast. It's characterized by dozens of atmospheric rivers every winter. That is, an atmospheric river is just a plume of highly concentrated atmospheric water vapor fluxing a lot of vapor in the air above your head in a manner that can produce potentially significant precipitation. It is the main moisture delivery mechanism in some parts of the West Coast, and so it makes sense that there's a lot of them. But I think the main reason why we hear about them more is there's been more of a concerted effort to understand them scientifically, and that has leaked out escaped containment, as they say on the internet. That language, you hear it on the evening news, you hear it on social media thread, you hear it in a Weather Service forecast discussion. So I tend not to emphasize the term in some cases, even when it is technically and meteorologically appropriate, or an event that might qualify nominally as an atmospheric river, if it's not a particularly consequential one, because even though it might be one, the impacts of it are not harmful, and sometimes people conflate atmospheric river equals big bad storm, and that's not always going to be true. Sometimes they're quite gentle or gradual or beneficial. In fact, it's true often. Sometimes, though, they can be a big problem, and I even, my personal usage of the atmospheric river term is kind of a balance of these two things. I don't reserve them only for the most extreme events, because there are notable atmospheric rivers that are truly qualify as such, even if they aren't going to cause big problems, and I'll talk about them in that context. If there's a nominal one that's only going to produce some modest rain somewhere, I just tend not to emphasize the term, even though it might still be technically correct to do so for those who choose. So it's kind of a communications choice. I would say the main thing to understand is that the climate of the west coast of North America is characterized by a lot of atmospheric rivers. That's been true historically, and it's true now. And if we're in a drought, the answer is probably because we've seen too few atmospheric rivers, and if we're having a flood, it's probably because we've seen either too many of them or a handful of very intense ones. And so they really do tell the tale of West Coast hydroclimate and their scarcity or in their overabundance. That's really the story of drought and flood. So they are that important. I don't have any issue with people using the term. Personally, though, I only tend to really emphasize it when they're at the upper end of the intensity spectrum, let's say. Oh, and there's a follow-up that the atmospheric rivers used to be called Pineapple Express, but that term fell out of favor partly for good scientific reasons, mainly because a lot of them do not originate in warm subtropical regions where you might find pineapples, for example, although that term is still used, by the way, to describe atmospheric rivers that have origins specifically in the subtropics near Hawaii. So You will still hear the term used by meteorologists occasionally to refer to a subset of atmospheric rivers that have origins in their moisture source near the Hawaiian Islands. There are other atmospheric river corridors that have specific names. There's the Mayan Express for deep tropical sourced atmospheric rivers that have moisture sources over Mexico, or the Gulf of Mexico at least. There's the Mango Express, which has to do with West Pacific warm subtropical atmospheric rivers. They're colloquial terms that are sometimes used in scientific literature. Again, they're not wrong in any way, so I don't have any real issue with people using them in the right context, especially if it helps give some actual information. Pineapple Express, for example, does suggest that a particular atmospheric river might have more moisture and warmer temperatures than a non-Pineapple Express atmospheric river. So as long as it has some meaning to it, as is true in that case, then I'm all for it. It's a question from someone self-described as the guy responsible for all the downtown planters in Santa Barbara. How bad is it going to rain here? I have several planters to finish over the next week. It probably will be a pretty significant rain event in Santa Barbara. It's looking like you'll see at least a couple inches of rain and maybe more than that. So if it's something that is rain sensitive or runoff sensitive, there could even be some local street flooding or ponding. That's probably something you want to get done the next 24 or 36 hours if you can. Again, this doesn't look like an extreme flood event or anything, but there could be some local flooding, especially because there's been a bit of an uptrend in the amount of rain for the Central Coast in LA this weekend specifically. And there's a comment from Eric Fielding that the projected intensity of the atmospheric river in Los Angeles this weekend is a scale of 2 out of 5. I don't know if that's updated or not, but I'll assume it's true. The challenge is that AR scale does not really tell you very much about how much rain is actually going to fall from a given atmospheric river. In fact, I think in recent years you've seen a lot of atmospheric rivers that punch both above and below their weight according to that scale. So it's really imperfect. And I think this one in Southern California is one that's going to punch above its weight on the scale because it's going to produce quite a bit of rain. And it could be pretty intense rain, even though it's not fluxing towards the coast pushed by really strong winds. There's a lot of moisture, and the efficiency of the atmosphere in squeezing that moisture out is going to be pretty high. Compared to a couple of weeks ago when we had a Category 5 atmospheric river in Northern California, and I think a lot of people didn't notice it. So I think that might illustrate that it's a scale that really doesn't tell us as much as we might like to think that it does about impacts in terms of the severity of rain or flood impacts. You can get a Category 4 or 5 atmospheric river with minimal harm, and you can get a Category 2 or 3 atmospheric river with actually quite a bit of rain and flooding associated with it. So there are other pieces of context that are important as well. Okay, so I know we're 5 minutes from the top of the hour, but I'll give it another 10 or 15 minutes beyond that if there are Ask Me Anything relevant questions. So let's shift gears to the Gates Climate Memo. And just to remind folks, at the very beginning of the chat, there is a link to my YouTube video op-ed on this topic. And that's from last week. But it's in response to the Bill Gates authored climate memo the week before that essentially argues that we should be pivoting away from trying to reduce our emissions to slow and eventually halt climate change in favor of poverty reduction measures. That's sort of the core argument, at least as I interpreted it after having read it 3 or 4 times. And by the way, you can feel free to start adding questions to the chat, comments to the chat right now, because this is where I'll be looking for this Ask Me Anything session. But I think I and I know a lot of my colleagues in the climate and earth system science world really struggled with this one because we really wanted to agree that we really do need to take things like poverty reduction and ensuring food and water and energy security for the billions of people who do not still have reliable access to those things, and that should be an even greater global priority than it is. And so I think a lot of us came into this thinking we would probably agree with the notion that we can't solely focus on climate change. We also need to address these other problems. But the problem, though, is that almost all of us came away from it saying, wait a minute, it does not really seem like the author of this memo understands just how bad a 2, 2.5, or 3 degrees Celsius warmer world will be. That's a world that's about twice the level of warming above the pre-industrial baseline that we've seen so far, so double the amount of warming we've seen so far, so quite a bit. And that's a world that involves much greater climate impacts than the first half of that warming. It involves, a 3C warmer world is a world that I personally, as I reflected in the video op-ed, isn't one that I would want to live in, which I think should say a lot about what it would look like, because what it would look like is that we no longer have mountain glaciers. We no longer have coral reefs. We have heat waves in humid tropical and subtropical parts of the world that could kill you even if you're standing outside in the shade, not doing any active work, because the combination of heat and humidity exceeds your body's capacity. It's essentially its intrinsic capacity through sweating, which is humans' heat dissipation mechanism, to accumulate heat more slowly than you gain it from the environment. It would mean droughts and floods of unprecedented severity that dwarf the ones, even the most extreme ones we've seen in the news in recent years. It means sea level rise of at least several feet, and possibly many feet. We don't know. That's one of the great uncertainties, because the acceleration of the loss of ice from the continental ice sheets would really pick up between 2 and 3 degrees Celsius of warming. So this is not a world that would be certainly not easy to adapt to, and I'm not really clear on how we would adapt to it fully at all. Certainly our ecosystems would not be able to, and many of them would be lost. So the question of whether it's an existential threat to, all humans, I don't think that's probably true, but is it an existential threat for specific ecosystems? 100%. Is it an existential threat for people living in certain places in the world and for certain communities and certain societies? 100%. So I think it's a bit of a red herring. It's a false binary to say that global warming is either going to lead to the end of the world or the end of human civilization, or it's going to be quite manageable. The reality, as I reflect, is really somewhere in between, and it's probably somewhere closer to the really bad side of things than the really good side of things. And that's the challenge, is that there's a lot of posturing and assumptions being laid down right now that we will just be able to essentially magic our way out of this mess through technology. And I'm all for technology. All of the actual solutions to climate change involve lots and lots of new technology at huge scale deployed very quickly. So that's not what I'm saying at all. What I'm saying is overconfidence in the ability of our societal capacity to adapt to a 2 degree or a 3 degree centigrade, or God forbid a higher level of warming, which is still possible, by the way. We cannot rule out more than 3 degrees Celsius of warming by the end of the century, given our current constraints on the system. That is a world that is so much warmer that I don't even think economists have argued about what it would mean for global and national GDP, gross domestic product, and the economy. I don't think we have, that's so much warming. There's such a transformational change to the Earth system and to society by necessity that I'm not even sure that GDP is a meaningful number anymore in a 3C warmer world. So the notion that GDP would only change by a couple of percent seems just patently ludicrous to a climate scientist. So anyway, I'm going to have actually a further response to this. I've submitted an op-ed piece, and I will also offer an edited version of that op-ed, or maybe I should say unedited version of that op-ed, in the form of another YouTube video op-ed coming up in the next 48 hours, so stay tuned for that. But as I mentioned, I'm still soliciting questions in this Ask Me Anything session. So I've got a few coming in. I'll cut it off in a minute or two, but I'm going to start answering the ones that have come in on this section as well. Yeah, as Mary mentions, it's not like poverty reduction isn't important, but it's not going to stop us from getting hotter and hotter. And this is one of the frustrating pieces of this false binary. It's not to say necessarily that there aren't limited resources, as much as I wish it were true that we had infinite resources. It is true that in the real world that we live in, money and effort and time and capital, either financial or personal or political or otherwise, it does get allocated often to one thing or another. It's not truly a zero-sum game, but there are trade-offs, and that is true. But I think this notion that we can essentially say that, well, it's more important to address poverty, for example, than it is to address global warming. The problem with that is that the warming itself is greatly going to be exacerbating the preconditions of poverty, the preconditions of food insecurity in the first place, of water insecurity, of health inequity in the world. And so the problem with saying we need to address those other things, not climate change, is that we don't really get to address those other things without addressing climate change. Now, it's true that there probably needs to be some balance, right? But the balance is not let's abandon one and do the other, because if we do that, we're just going to be constantly playing catch up. We're never going to be able to reduce poverty to the level that we want to. We're never going to be able to improve food and water security and health equity to the degree that we would all like to globally, unless we address these things that are undermining it at an exponential rate due to climate change. And I think the problem is that it's true, perhaps, that for much of the 20th century, the global warming that we experienced was manageable largely, and that poverty reduction measures were essentially produced greater gains in global well-being than global warming produced harms. I'm willing to believe that that was true historically, but the problem is that is not going to be true moving forward, because the incremental disruption and destruction from each additional tenth of a degree Celsius of warming is greater than the last. It is literally a nonlinear function of the warming. It becomes progressively more and more disruptive, and a tenth of a degree, a quarter degree, a half a degree Celsius of warming, the first half a degree Celsius of warming is much less dangerous than the next, and the next is even much more dangerous than that one. So the fact that the risks build, that the consequences build, some of these folks who are arguing that it's manageable are really extrapolating linearly from the past. And the irony is a lot of these are big thinkers and tech thinkers, and the whole AI world, computer chips, Moore's law, lots of this is inherently nonlinear, and yet there's a lot of assumptions being made by people who are not experts in climate or the Earth system that future changes will also be linearly extrapolated from the past. And that is just not the case. And that is a critical error that completely undermines the argument that we should be pivoting from addressing one of the underpinning problems that causes or worsens or undermines efforts to reduce, or perhaps even reverses, what are arguably great global successes in reducing poverty in recent decades. All right, I'll look and see what else is coming in. Well, I'm not seeing a great deal of questions in today's Ask Me Anything, which maybe is maybe that's a form of shocked silence. I don't know, but I do think that the real challenge of the moment is trying to resist oversimplification of the problems at hand and the way the world works, and to really make sure that we're fully cognizant of what the full range of outcomes actually looks like in a warming world, and I don't think a lot of folks who are very prominent public voices in this space actually get it. I really don't, and that deeply concerns me. That there is such again, I've used the word glib more than once, but it really does seem like there is an almost shocking lack of understanding regarding just how profoundly changed a 2.5, 3 degree Celsius warmer world actually would be. And again, we cannot rule out still more than 3C of warming by the end of the century. It's not the most likely outcome, but it is very much still within the realm of possibility. And recent evidence doesn't instill confidence, by the way, that we're going to get lucky with Earth system sensitivity and the amount of warming that we get per increment of heat-trapping greenhouse gas emissions. There's uncertainty as to exactly how unlucky we're going to get with that. But it does look like some of the better estimates, the more optimistic lower-end sensitivity estimates, do not appear to be panning out. So that's not to say that the most extreme ones are the most likely ones either. But it does look like the likelihood that we get really lucky and see a very low amount of warming per greenhouse gas increment emitted is looking less and less likely. And so that should give us pause in making assumptions that we will get lucky with the Earth system, that we'll get lucky with global geopolitics and the sequence of events moving forward. And I think we need to have an honest conversation about where we are and what the uncertainties and the realities of the world that as they may unfold in the coming decades actually are. And then a couple of questions did just come in as to why there seems to be such a divergence between a lot of the prominent global voices in climate advocacy and policy world right now and climate scientists. And that is an excellent question that has very complicated answers that are partly related to what's in the news even today. And honestly, I don't necessarily want to speculate on personal motivations, but the reality is, the fundamental reality is, what I can concretely say as a climate scientist is that the depiction of the consequences of the kind of warming that we're still on track to see are so off target that they fundamentally undermine any other arguments I think that a lot of these folks are making right now. I just don't think they get it, and I don't know exactly why that is, because there's certainly a lot of climate scientists out there shouting from the rooftops about what that world would actually look like. And perhaps it's that these folks don't believe climate scientists. Perhaps it's that these folks are listening to the still much more prominent fossil fuel funded voices of denial in the room, who are very much in this particular room, I would add. I don't really know beyond the same old stuff that we've been seeing for decades in climate world, where there are a lot of really well-funded people who are just essentially lying about the way the world is, and a lot of much less well-funded people who are trying their very best to counter what are essentially fundamental factual inaccuracies, but maybe more challengingly rhetorical red herring arguments, things that are not perhaps technically untrue, but are deeply fundamentally misleading because they are so wildly out of context as to be essentially meaningless, but are used rhetorically to essentially make almost exactly the opposite point as what the more reasonably contextualized facts would actually show. It's ever the challenge, and it becomes even more important, I think, in this moment. All right, well, I think that might be a good place to leave it. Again, I'll have another shorter video op-ed out later this week, kind of in response to the response, if you will, to this piece. But thanks for your attention. If you're in Southern California, this will be a significant rain event Friday into the weekend, and there could be some flooding. This has sort of trended upward. This does not look like a big snow event in the mountains. It's going to be too warm for that. So the Sierra Nevada could see significant rain. Still moisture, but it's not snow unless you're up at 9 or 10,000 feet. And I will be following on social media as always, amid many other things I have to get done between now and Saturday. All right, thanks all for listening, and I'll talk to you next time.